Hello, Moniba. Good evening.
Good evening, ma'am.
Okay, so have you practiced the aldol condensation mechanism?
Yes, ma'am.
Okay, so we were doing the aldol condensation, right? So we just discussed one question based on the aldol condensation, which is for the aldehyde. Now let's try for the ketone. Okay, we will see the same mechanism, aldol condensation, self-aldol condensation. Okay, so as I explained it in the previous class, there are two types of aldol condensation reaction. First one is your self-aldol condensation. Self-aldol condensation is the similar molecule, same molecule. You will take the 2 moles of same molecules. Okay, and you will do the same mechanism. Second is the cross-aldol condensation. Cross-aldol condensation is the reaction of different molecules. Okay, different molecules, and different molecules could be your aldehyde and it could be your ketones. Okay, and it could be one aldehyde and one ketone. So that is your cross aldol condensation. So we will discuss both your self condensation and cross condensation, right? So let's revise the mechanism of aldol condensation. So this is your 2 moles of CH3COCH3. 2 moles of CH3COCH3 acetone. Okay, we will do the aldol condensation of acetone. So first, what I explained you, CH2, you will write 1 mole like this, CH2, okay, and hydrogen over here, COCH3, okay, and it is a base catalyzed reaction. Aldol condensation is a base catalyzed reaction. So this base will give you OH minus ion, right? So this OH minus ion will abstract this hydrogen. When it abstracts this hydrogen, right? So H2O, basically it will liberate out. And here on this carbon, there will be a negative charge. Okay, means the carbon 9 will be formed. Okay, now, so the next step, another mole of this ketone, another mole, which is your CH3, COCH3, right? Now, you know very well this carbon, between this carbonyl compound, this is carbon and oxygen. Oxygen is more electronegative, right? And this carbon is electropositive. So this carbon will acquire partial positive charge. So this carbon ion will attack this positive center. Okay, so this bond will close. Now you will start writing from here. Okay, CH3, CH3. Now this carbon, right? This carbon and this oxygen, which is having negative charge now. Okay, and now this CH3 you will write here, this CH3. So this is the part of the this mole. Okay, CH3, CO minus and CH3. Now this CH2, okay, this CH2 attacks this carbon, right? So it will attach over here. So you will write CH2, start writing from here, CH2, this one, CO, and this is your CH3. Yeah, is this clear till here? Muniba and Aisha?
Yes, ma'am.
Yes, ma'am.
Okay. Now, when you do further acidification, when you provide H plus ion, okay, when you provide H plus ion, so this H plus ion will attack this oxygen, will get attached to this oxygen, and it will give you a OH, CH3 over here. Yes. Now tell me what is the name of this compound? What is this? Yes, Muniba?
Beta hydroxy keto.
Yes, ketone. And what we call the commonly what we call it as ketones, right?
Yeah.
Yeah, because we are just taking the ketone and we are just doing the aldol condensation. So in the case of ketone, this is this compound beta hydroxy. So this is your CO group, right? CO group. So this carbon is known as alpha group. This carbon is alpha carbon and this carbon is beta carbon, right? So this carbonyl compound, this carbonyl group is attached to this carbon. So this carbon is known as alpha carbon and this is beta. So what is this? This is the beta hydroxy ketone, and beta hydroxy ketone is known as ketones. Ketone. Okay. Now, and you can also write down the IUPAC name. IUPAC name is very easy to write the IUPAC name. So it will be, first you will choose the parent chain, right? So parent chain is this one. This is the parent chain, right? Now this is beta. Okay, means this is a if you start numbering from here. So this is first carbon, second carbon, third carbon, and now this is fourth carbon. So on the fourth position, there is a hydroxy group, 4 hydroxy, right? 4 methyl, and what is this? 1, 2, 3, 4, 5. Okay, pentane, pentane, 1 on. No, sorry, 2 on. This is second carbon, right? On the second carbon, ketone is there. So pentane 2 on. 2 on you will write. So that is the name. Okay. Next is, as I explain, so the aldol and ketones can easily undergo dehydration, right? So there will be a dehydration once the ketone is being formed, right? And the dehydration will, basically dehydration कैसे होता है? The OH, okay, OH from the beta position. You have to remove OH from the beta position and one hydrogen from the alpha position. One hydrogen from the alpha position. So H2O will be removed, means dehydration will occur, and there will be a unsaturation double bond. Okay, there will be a double bond between alpha and beta position. Okay, so you will write CH3 double bond. This will become CH. Okay, when the one hydrogen has been removed, CO. Okay, so this is your final product. This is your final product. Is it clear? The whole mechanism?
Yes, ma'am.
Yes, ma'am.
And what is the name of this compound? Can anyone tell me? Final product name.
Methyl,
4-methyl,
4-methyl pent in
4
enone.
methyl, yes, pent 3-enone. Pent 3. Okay, on the third position, there is a double bond. So, enone. Very good. Okay, let me discuss some more examples. Now, if we have in your exam, if they don't ask you the whole mechanism, then no need to waste your time. No need to waste your time of writing. No need to write down the proper mechanism. Now, I will give you some trick so you can only write down the product in that case. So, suppose, let's take the example. Suppose we have CH3, CH2, and CHO, right? So basically, we will take the 2 moles, okay, 2 moles, and it will be under base catalyzed, okay, dilute NaOH you are providing. Okay, now what you are supposed to do? So you will write 1 mole like this, CH3, CH2, okay, and you will write CO and 1 hydrogen. This is the first mole. Okay, this is an example of the self condensation. Okay, not the cross condensation, because you are just taking the two same molecule. Okay, two same molecules का आप condensation करा रहे हो, so that is your self condensation. So CH3, CH2, CHO. Okay, first mole. Now second mole, how you will write? Just start writing from here. CHO. Okay, this will become CH2, and you will write the last. Your this one. Okay, not the last one. Basically, you will write down the alpha carbon. Okay, you will write this is your alpha carbon, right? This is your CHO group. CHO group is attached to this carbon, so this is your alpha carbon, and this is your beta carbon. So सेकेंड मॉलिक्यूल को आप कैसे लिखोगे? CHO, this alpha carbon, you will write like this carbon, and you will show two hydrogen, and the third one you will write as it is. Okay, now see. So both are same molecule, but the way of writing is different. Okay, for the ease of writing the product, so say basically this CHO group, right? So from here, what you're supposed to do, this is your alpha carbon of the second molecule, and this is your carbonyl carbon, okay, CHO group. So this carbon will get attached here, okay, to the alpha carbon. This carbon will get attached to the alpha carbon, right? And this hydrogen, okay, this hydrogen will get attached here with the oxygen, and you have to break this one bond. Break this pi bond, okay? Break this pi bond of the carbonyl group. So this next, so what you will get? You will get CH3, CH2, okay? This will become CH, right? CH, and basically this hydrogen is being shifted over here, okay, and one pi bond आपने break कर दिया. Now this carbon is getting attached to this one carbon, okay. This has one hydrogen, so I'm just writing like this hydrogen, and this CHO group, and this one group, this methyl. Is this clear? Is this a step clear what we are supposed to do? Yes or no?
Yes, no.
Aisha, is it clear? If not, I can repeat. Okay, clear. Okay, so this is what we get. Now, what is this? This is your beta hydroxy aldehyde. Okay, we just got the aldol. We just got the aldol. Now, once we got the aldol, what we are supposed to do, you know very well, this is alpha position, this is a beta position. So, OH from the beta position and alpha from hydrogen from the alpha position, right? Hydrogen from the alpha position. So, basically, this H2O will be removed. Dehydration will occur. Okay, H2O, this H2O, OH and hydrogen. OH from the beta position and hydrogen, one hydrogen from the alpha position. Okay, and you will get a double bond between alpha and beta position. Okay, double bond. So you can now write CH over here, and this will become, okay, okay, this is what you will get. This is the final product. Is it clear? Yeah. So see, it's very simple. First, you will write down one molecule like this, CH2, CH3, CHO, and you will write like this, CHO group. Okay, aldehyde group like this. And the second molecule, okay, the second molecule, you will show the alpha carbon. Okay, alpha carbon and this alpha two alpha hydrogen, you will show like this. Okay, and you have to attach this carbon. Okay, the one molecule carbon, this carbonyl carbon to this carbon, okay, alpha carbon. And this hydrogen, one alpha hydrogen will get attached over here to the oxygen and just break this pi bond. So you will get this one. You will get the aldol. Once you get the aldol, now it's very easy. You know very well from the beta position, you are supposed to remove OH and hydrogen from the alpha position. So dehydration will occur and you will get the unsaturated, okay, alpha beta unsaturated carbonyl compound. And this is your final product. This is your final answer. Clear, Maniba? Now, if it is clear, then do these questions. ओके, एसीटोन का मैंने डिस्कस कर चुकी हूँ मैं. Okay, let's not waste time. I think it's clear, right? So we have already discussed the acetone. Okay, your aldehyde. Second thing मैंने acetone के किया था CH3 COH. Okay, then your acetone, then your this compound. Okay, so three examples are okay. They are enough. Now, next
Um,
thing, let's understand the cross aldol condensation. Yes, Maniba, any doubt?
No, I wanted to ask, but when are we going to complete this chapter?
It will complete in the next class, inshallah.
Okay.
Okay, and after that, which chapter you want to start?
I mean,
Okay, so we will start with the means after this. Okay, so yeah, so cross aldol condensation. Cross aldol condensation. Okay, so cross aldol condensation, as I told you, the condensation reaction between two different molecules of an aldehyde or ketone. Okay, now, so in this condensation is basically between two different aldehyde or two different carbonyl compounds. One should be it can be between aldehyde, but both the aldehyde should be different. If you are just taking the one formaldehyde, so the other molecule you will take different other than the formaldehyde. Okay, between two different aldehydes हो सकते हैं reactions, between two different ketones, or between one aldehyde and ketone. So that is the cross aldol. So both the molecules should not be same. If they are same, so then it is not known as cross aldol. It will be called as self aldol condensation. Okay. Now let's understand the mechanism of this. Let's take example. Suppose we take CH3CHO. Okay, CH3CHO. First, I'm just taking both the aldehyde group. Okay, this is CH3CHO, and the second molecule, if I take formaldehyde. Okay, and in the presence of same, this is again a base catalyzed. Okay, dilute NaOH. Okay, so now see. CH3CHO. What is it? This is your acetaldehyde. Acetaldehyde. And what is this? This is your formaldehyde. Now let's understand the mechanism. So first you can see, oh, this is your CH2 and one hydrogen. Okay. So this acetaldehyde, I'm just writing CH2 and one hydrogen over here, CHO. Okay, the mechanism will be very same. Okay, this occurs in a basic condition. So the OH minus will abstract this hydrogen and it will form carbon ion on this carbon. Now, what is the next? This is the other molecule, formaldehyde, right? So this carbon ion will attack this carbon, okay, and this bond will shift over here and it will form H. What it will form? Now write it down, H. Basically, you will write, okay, CO minus. So this carbon, you can see this carbon has two hydrogens, so you can write H2C. Okay, this carbon, I'm just starting from this formaldehyde. So this carbon has two hydrogens. So I'm just writing combinedly H2 and this C. And carbon with negative, or oxygen which is having a negative. Now, this whole thing will get attached over here to this carbon. So it will become CH2 and COH. Okay, that is the step. Next step, when you give H plus ion, okay, so it will form COH over here. Okay, the hydrogen will get attached to this oxygen and it will form this CH2. Okay, and here OH, CH2OH, and CH2OH, and this will become CH2CH. Okay, और इसे आप कैसे लिख सकते हो? Just like that, just a straight chain, OH over here. Okay, OH, this is CH2, CH2, and this is your CH. Okay, one terminal on the one at the one terminal there is a aldehyde group, and the other terminal there is OH. Okay, so that is what is this? This is your beta hydroxy propanaldehyde, 1, 2, 3 carbon, right? Beta hydroxy pro Okay, beta hydroxypropanaldehyde, which is also known as aldol, which is also known as aldol. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, quickly write it down. When you do the further so this OH, okay, from the this is alpha position and this is beta position. OH from the beta position and the one hydrogen from the alpha position. Just remove this as a water and you will get CH2 double bond CH and CH. Okay, this is your final product. Okay, okay, next. So I will provide the notes after this class. Okay, so next, suppose we just take another example, second example. So we just take CH3CHO plus HCHO. Now another example, if suppose we just take CH3, first let's understand something. Okay, if we don't have to write on the mechanism, then how we can write down the product only. Suppose we have, suppose we have, okay, CH3, okay, your CHO. 2 moles of this dilute NaOH. Okay, if you are writing 2 moles of CH3CHO, so what is this? This is a self-condensation, self-aldol condensation. So how you will write? You will write CH3, okay, CH and double bond oxygen plus another, you will write CHO, okay, and you have to write on the alpha carbon like this, okay, alpha carbon and hydrogen like this. So this one oxygen, okay, one oxygen from this CO group, okay, from the first molecule and two hydrogen from here, okay, they will be removed as a water. Okay, so dehydration will occur. Both the compounds are same. CH3, CHO, CH3, CHO. But आपको इस तरह से लिखना है. First one, CH3, CHO, and the second one, you will write down the alpha carbon and alpha hydrogen like this, so that you can easily dehydrate from that. So dehydration will occur, two hydrogen from the alpha carbon of the one molecule and the oxygen, okay, this carbonyl oxygen from the other molecule, they will combine and they will be dehydrated. Okay, the water will be removed from that. Okay, so when the water will be removed, you will get a alpha beta unsaturated carbonyl compound, and that is your final product. That is your final product. So what you will get? CH3, this will get CH, okay, and this will get attached over here with the double bond CH, okay, and CH. That is your final answer. Okay, this is a self-aldol condensation. Self-aldol condensation, if you will write one molecule like this, second molecule like this. Okay, so from the first molecule, you have to remove one oxygen. Second molecule, say you have to remove the hydrogen, two alpha hydrogen and one oxygen will get combined, and the water will be removed. When the water will be removed, dehydration will occur. You will get a alpha beta unsaturated carbonyl compound, and that is your final product. And this is the product of self condensation. Self condensation product. Okay. Another example, let's take cross aldol condensation example. Suppose we just take 1 mole CH3 first terminalia acetone. Okay, this is your acetone, ketone, plus another, I will take CH3, CH. Okay, and if I ask you when you add, okay, these are the two reagents, okay, two reactants, and if you add dilute NaOH, so what will be the product in this case? Write down the product. So how you will write down the product? So this is this is your cross aldol condensation, right? You can see this is your ketone. Okay, another if two different molecules are reacting over here, so this is your cross aldol condensation. Okay, and no need to write down the proper mechanism, but understanding mechanism is very, very important. You should know the mechanism. Okay, so what you're supposed to do, just write down this ketone like this, CH3, okay, CO, okay, and the CH. This is your ketone. Now, from this alpha carbon, this is your aldehyde, right? This is aldehyde group, CHO group. CHO group is attached to this carbon, so this is your alpha carbon. So you will write alpha carbon, okay, and the alpha hydrogen like this, okay, 3 hydrogen. Molecule is same, but the way of writing is different, okay. And what you're supposed to do again, just do the dehydration, and you know how to dehydrate. Oxygen from this, okay, and 2 hydrogen from this. Just removed it, okay, and you will get the product. Just jahan se oxygen remove, where you have to attach this carbon to this carbon, to this alpha carbon, right? So CH3, this carbon, okay, this carbon, the oxygen has been removed, and this CH3 as it is. Now this will get combined by a double bond, and you just have to combine this carbon by a double bond. This carbon has 1 hydrogen, so you will write 1 hydrogen, and this CHO group as it is. So that is your final product. You can check over here. This is alpha, this is beta. Alpha beta unsaturated carbonyl compound. Is this clear?
Yes, ma'am.
Okay. Now, if I give you another example, now tell me the product. I'm just giving you 2 questions, and one by one I will ask you. Third question. Suppose if I take CH3 CHO group plus CH3 CO CH3 group. Okay. And in the presence of dilute NaOH. So what will be the product? Write down the product. Then the fourth question is, when you take CH3 CHO plus your, okay, this is again an aldehyde, and I'm just taking one aromatic aldehyde, benzaldehyde. The condition is same, dilute NaOH. Okay, now quickly write down the product. Use the same mechanism and write down. And okay, see what we are supposed to do. In the first one, CH3, CHO. So how you will write this? CH3, and we can write this as CHO. Okay, this is CHO aldehyde group. And this group, you will write this like this. Okay, and this is your alpha carbon. There are two alpha carbons. So you can do any alpha carbon. You can write like this carbon and three hydrogen like this, right? Now, it's very simple, two hydrogen from alpha carbon and one oxygen from here. The water will be liberated out and you will get CH3, CH. Okay, and just attach this and this carbon by a double bond. Okay, so you will get CH again, CO, CH3. That is the product. Similarly, second one, CH3, CHO, right? And this is your aromatic aromatic system. Okay, benzaldehyde. So how you will do this? So suppose if you take so here, because see, yeah, again, I'm just telling you one thing. In this question, you can see one has alpha carbon, okay, and this compound has no alpha carbon, right? So this CHO. This CHO group is attached to this carbon, right? See this. This is your this system. CHO, right? Now this CHO is attached to this carbon. Now check this carbon. Is this carbon has hydrogen? No, it has no hydrogen. It has no. So this compound has no alpha hydrogen. This carbon has four bonds. One, two, three, four. Means it has no alpha hydrogen, right? So if you are just doing the self aldol condensation, and if one compound has no alpha hydrogen and one compound has alpha hydrogen, right? So you will choose this. You will remove the oxygen from that compound which has no alpha carbon, which has no alpha carbon. So this has no alpha carbon, right? Has no alpha carbon. So you can write like this: C, okay, H and double bond oxygen plus this you will write CHO, okay, and this carbon which has three hydrogen. Okay, again, I'm just telling. If suppose this is not for all the cases, okay, you have to analyze the question. Which type of question is this? What are the reagents over here? So if you have given two reagents, okay, two different molecules, and one is having alpha hydrogen, okay, one compound के पास alpha hydrogen है, and the other compound lacks alpha hydrogen, right? So for that type of question, you will remove oxygen, okay, because basically you have to do the dehydration. You have to remove two hydrogen from one alpha carbon, okay, alpha carbon, and one oxygen from the other compound, okay, one oxygen from the other compound. So you will choose that compound which has no alpha hydrogen. You will choose that compound which has no alpha carbon and just remove oxygen from that. Okay, so just remove the oxygen from that compound which lacks alpha hydrogen, And the if you are just removing oxygen from this, okay, so the other thing आप क्या कर सकते हो? You will remove two hydrogen to alpha hydrogen from the other compound. Okay, so for this type of question, we will do that. So what you will get when you remove this oxygen, okay, and this two hydrogen, so dehydration will occur, and you will write like this CH. This is having, or you can write phenol ring, this thing, and it has CH, okay, and it's attached to this carbon. Double bond CH and this CH group. So you will get this product. Is this question clear, Muniba and Aisha?
Yes, ma'am.
Yes, ma'am.
Okay. Similar case आपका मैंने कराया था just like a formaldehyde. Okay, this was a similar case. Acetaldehyde and a formaldehyde. Acetaldehyde and a formaldehyde, right? So this acetaldehyde, Okay, this acetaldehyde has one alpha carbon, right? This carbon, this CHO group is attached to this carbon, which has a hydrogen, right? So it has a alpha hydrogen. But you can check this CHO group is attached to this hydrogen. This attached to this hydrogen. This is attached to this carbon. Okay, it has no other carbon. It has no your alpha carbon. Okay, and alpha carbon nahi hai, so how the alpha hydrogen is present? Okay, so alpha hydrogen is absent in the formaldehyde, and in the acetaldehyde, alpha hydrogen is present. So this is again this type of question. So you will remove the oxygen from this formaldehyde. Okay, so what you're supposed to do if you don't have to write down the proper mechanism, what you will do, this is CHO group, right? Plus this is your okay CHO, and you will write this alpha carbon. Okay, this molecule contains alpha carbon, so you will write like this. Alpha hydrogen आप ऐसे लिखोगे. And this formaldehyde has no alpha carbon. It lacks alpha carbon. So it lacks alpha hydrogen also. Right? So these two hydrogen is attached to this carbon. Okay, not to the other carbon, not to the alpha carbon. Okay, so you can't consider this hydrogen as a alpha hydrogen. It is not an alpha hydrogen, right? If it is attached to the alpha carbon, then only it is a alpha hydrogen. Now, what you're supposed to do? So, in the molecule which lacks alpha hydrogen, you will remove oxygen from that and two hydrogen from here. Okay, and now you can write down it will be CH2, okay, double bond CH. Now you can check the answer. This is the final answer. Yes, CH2, CH. Okay, so no need to write down the proper mechanism if in your exam they don't ask. Okay, just write down the mechanism if they ask in your exam. If they just ask you to write down the product only, so you can do this. Great. Okay. Okay, so this is all about the aldol condensation, self-aldol condensation, cross-aldol condensation. Any doubt in this? Aisha and Muniba, is this concept
No,
clear?
ma'am. Yes, ma'am.
Okay. Now, next reaction, write down Cannizzaro reaction. This is again a name reaction, so it is again important. Cannizzaro reaction. Okay, so what is Cannizzaro reaction? So see, we were doing the alpha aldol condensation. Aldol condensation reaction is that reaction, okay, in which in which alpha hydrogen is present. Alpha hydrogen is present, okay, in any of the compound. If you are just taking the 2 moles, so one compound should contain the alpha hydrogen. Okay, then only the aldol condensation will be done. But the Cannizzaro reaction, write down this reaction is given by aldehyde, aldehyde and ketones that lacks alpha hydrogen, that do not have alpha hydrogen. That is the difference between aldol and Cannizzaro reaction. Cannizzaro reaction is given by that carbonyl group, that carbonyl compound that lacks alpha hydrogen. Okay, and basically what happens, Cannizzaro aldehyde that do not have alpha hydrogen undergo self-redox reaction. Okay, so one molecule will undergo self-redox reaction, means oxidation as well as the reduction. Okay, both the reaction will occur here simultaneously in the presence of concentrated alkali. Okay, again you will use the alkali over here. Okay, now you can also write here. So aldehydes and ketones that do not have alpha hydrogen undergo self-oxidation. Basically, you can write down the carbonyl group. They undergo self-oxidation and reduction. On treatment with on treatment with concentrated alkali. Okay, and this reaction, Cannizzaro reaction, because it is a self-redox reaction, the one molecule will undergo a oxidation as well as the reduction process. So this is also known as disproponation reaction. What we call this? Also, it is also known as disproponation, reaction. For example, now the question is which type of compound lacks alpha hydrogen? Okay, suppose example लिख लो आप. Example like HCHO, formaldehyde is a very good example. Formaldehyde, you can see it lacks alpha hydrogen. Your benzaldehyde lacks alpha hydrogen, right? Now see, suppose we just take the example. Mm, let's take the formaldehyde example. 2 moles of HCHO हमने लिया. Okay, this is formaldehyde, 2 moles. Okay, which when we add the concentrated alkali, sodium hydroxide, when we add the concentrated alkali, sodium hydroxide, so what will happen? So this formaldehyde will undergo a redox reaction. Okay, so इस formaldehyde का क्या होगा पहले? Reduction. Okay, so reduction is the, what is reduction, Aisha? What is the reduction? No? What is the reduction process? Can you explain me like 1 to 2 points? No? Okay, so reduction is a removal of oxygen or the addition of hydrogen. Addition of hydrogen or the removal of oxygen. So what we are supposed to do, this is your HCHO. HCHO. Okay, so in the reduction, what we are supposed to do, you have to break this pi bond, add 1 hydrogen to the oxygen and 1 hydrogen to this carbon. Okay, so this formaldehyde will undergo reduction. Reduction में आपने क्या करना है? The addition of 2 hydrogen. You have to add 2 hydrogen. Okay, and just break this pi bond. Okay, just break this pi bond, add 1 hydrogen to the oxygen and 1 hydrogen to the carbon. So you will get a alcohol. This CHO group, aldehydic group, will get converted to a alcohol on reduction. So what you will get? You can see CH3. Okay, this is CH3 and OH. You will get methanol plus. Okay, next thing. So it once go reduction. This is the reduction product. Now when it undergo oxidation. So oxidation में आपने क्या करना है? And yeah, it is in the presence of Na. Okay, sodium. So basically, the oxidation product will be the carboxylic acid. When aldehyde undergo oxidation, right? In the concentrated sulfuric acid, not a sulfuric acid, sodium hydroxide, alkali. So it will form a carboxylic acid, right? This aldehyde group will convert to a carboxylic acid. But here it is a sodium. We are using the sodium hydroxide. So now it will form a salt, right? It will form a salt. Now check it. So what it will form? The number of carbon will be same. What you are supposed to do, just add 1 oxygen. So it will be HC. Just remove 1 hydrogen. 1 hydrogen remove करोगे और एक और हाइड्रोजन एक और ऑक्सीजन आप ऐड करोगे. So HCOO minus and this is Na plus. So it will be formed. So when formaldehyde, okay, what is Cannizzaro reaction? So here examples ये लेते हैं. Formaldehyde will undergo a redox reaction. First, reduction product will be your alcohol, and your oxidation product, it will undergo oxidation, oxidize to a carboxylic acid. But here you are using the alkali, sodium hydroxide, so you will get a salt for that, right? So this NaO, you can show that. What is this? This is your oxidation. This is your oxidation, right? So on oxidation, we just get the carboxylic acid, but here it is sodium. Here we are using the sodium hydroxide, so you will get a alkali, salt, Na plus salt. And now what is this? This will reduced. ये reduction हो रहा है यहाँ. It will get reduced to a CH3OH group. So that is your redox reaction. Clear? And that is known as Cannizzaro reaction. Is it clear, Maniba?
Yes, ma'am.
Okay. Okay, so now let's move further. Suppose I'm writing it. Now, how we can determine, suppose we have to determination, write down determination of reactant. If the question asked in a different way, so you will be given a product and you have to, they will ask you how you will determine the reactant. What will be the reactant for this product? Okay, so this is a part of the aldol condensation, determination of reactant from products of aldol. Okay, so ये भी आपको पता होना चाहिए. First case, if beta hydroxy aldol aldehyde or ketone is given. Beta hydroxyaldehyde or ketone means aldol or ketones will be given. If that is given, so how you will write down the reactant for that? Suppose let's take a example: CH3, CH2, CH, CH, CHO. Suppose this is the alpha carbon. So alpha carbon पे आपका methyl group attached है, and here on the beta position there is a OH group. So what is this? This is a alpha beta hydroxy, right? Alpha position, beta carbon. So on the beta position, there is a OH group. So what we call this? Beta hydroxyaldehyde. Beta hydroxyaldehyde. Now, if beta hydroxyaldehyde is given, so how you will predict the reactant? Okay, so see here. That is very easy. First, you have to analyze the question which group is given, whether it's a beta hydroxyaldehyde or beta hydroxyketone, right? And now after that, just check which carbon is alpha carbon, which carbon is beta carbon. Okay, you have to basically select the alpha carbon or beta carbon. Alpha carbon and beta carbon identify कर लिया आपने. This is your alpha carbon, this is your beta. First step. Second step, just break this bond. Break this alpha and beta carbon, this bond. You have to break this bond. When you break this bond, next step क्या होगा? Just change this OH which is present on the beta carbon, right? This beta carbon पे जो OH है आपका, just change this group to your CO group, carbonyl group. This OH group will get converted to a CO group, okay, carbonyl group. Okay. After that, okay, let me write down the step over here. I'm writing the step over here. First क्या करोगे आप? You have to identify alpha and beta position, right? Beta carbons आपने select कर लिया. Second step, okay, just break alpha beta, okay, alpha beta bond. Okay, next step, just change OH will get converted to a double bond oxygen. Okay, आपको carbonyl group बना देना this OH का. And next step will be you put one hydrogen on alpha carbon. Okay, one hydrogen on the alpha carbon. That is the thing. Okay, so first आपने क्या किया? You have to identify alpha and beta carbon. Second, just break this bond. Third step is this OH will get converted to a double bond oxygen, right? Double bond oxygen, and this you have to add one hydrogen on the alpha position. Now let's see. So first हमने break कर दिया bond, CH3, CH2, and this CH. Okay, and आपने ये भी लिख दिया this bond. This is CH3, CH, and this CH. Second step, break कर दिया आपने bond. This OH will get converted into a double bond oxygen, right? So this OH will get converted to a double bond oxygen. So what is this? This will become CHO group aldehyde. This will become aldehyde group. And just put one hydrogen to the alpha carbon, right? So you can satisfy the bond. This carbon is tetravalent. Okay, it should be connected to four bond. But here one bond is lacking. One, two, three, and so you will add one hydrogen to that. So it will become CH3, CH2, CHO. So these two are the reactants. When you react these two, okay, both are the aldehydes, CH3, CH2, CHO group. And what is this? Can you tell me which type of condensation it is, Muniba? Self or cross?
Um, Cross
Why it is cross? Why it is cross?
because
Both the molecules are same. Both the molecules you
um
can check CH3, CH2, CHO. CH3, CH2, CHO. Both the molecules are same. So this is your self condensation. Okay. By
yeah.
analyzing the reactant, uh, you can also tell that this is a cross aldol reaction and this is a self aldol. Okay. So next question. Next question. Suppose. Okay, let me give you some questions. Let's check you understood the concept or not. Suppose first example मैं देती हूँ CH3 या CH2. Just do the same method. Use the same steps. This is the first one. Okay, again you have to tell me the reactant. What will be the reactant for this beta hydroxy, your aldehyde? Second question is this is your CH3, CH3, COH, sorry, here OH, CH2, CO, CH3. Okay, quickly do this. You can see the steps. These are the steps. First, identify the alpha and beta carbon. Then just break the alpha and beta bond. Convert the OH to a CO group, carbonyl group, and add one hydrogen to the alpha position. And you have to tell me what is this, whether it's a product of your self condensation reaction or cross condensation.
Both of them are self.
Yes, Muniba?
Both are self.
Both are self. Okay. And what is the and what are the products for the first one? Sorry,
CH3 2
three
C
CHO.
double plus CH3 CHO.
Very good. Okay, so both are same. So it is self condensation. This one,
CH3 C double bond O CH3
very good. So it's a
plus CH3 C double bond O CH3.
very good. So it is again a self condensation. But here we just got the reactant as a ketone. Okay, these are the ketone reaction, and this is your aldehyde. Okay. Now see the next case. Now, if they give you the saturated carbonyl group, alpha beta saturated, then how you will uh, save the bond and how you will write down the or how you will predict the reactant. So let's check it out. Second case. First case में हमने क्या देखा? When the beta hydroxy aldehyde is given or ketone is given. So how you will write down the reactant. Second case is if alpha beta unsaturated aldehyde or ketone is given. Ketone is given, right? So how you will write down the reactant. Okay, so example CH3 CH double bond CH 3H. Okay, so what is this? This is alpha beta. Alpha beta unsaturated aldehyde it is given. So write down the step what we are supposed to do. You have to just break alpha and beta double bond. Okay, double bond. आपने break करना है. Second step, add double bond oxygen. Okay, double bond oxygen means you have to convert this beta carbon to a carbonyl group, CO group. Add double bond oxygen on beta carbon and you have to attach two hydrogen atoms on alpha carbon. Okay, for the alpha beta unsaturated. Okay, so let's do that. Just break this bond, CH3, CH. Okay, just break this bond. Now, and this will become CH, CHO. Okay, add oxygen on beta carbon. So this was beta carbon, so just add the oxygen. So you will get aldehyde CH3 CHO group and add two hydrogen atoms on alpha carbon. So this was alpha carbon, so you will add two hydrogen. So one hydrogen was already there, so you will add two hydrogen, so it will become CH3 CHO. So these are the two reagents. CH3 CHO. It is again a self condensation because both the molecules are same CH3 CHO CH3 CHO. Clear, Muniba?
Yes, ma'am.
Okay. Suppose if I give you another third one. Okay. Now write down the reactant. Identify the alpha and beta carbon first. Just break the alpha and beta bond. Just convert the beta carbon. Okay, beta carbon में आपने क्या attach करना है? Just oxygen and alpha carbon, two hydrogen. Just attach two hydrogen. You will get the product or reactant.
Ma'am, self
Yes,
again,
Muniba.
both of them.
Done, both of them? Both are?
Yeah, self.
Okay. Okay, tell me the reactant.
CH3, CH2, CH double bond O
Okay. CH3,
plus
CH2.
CH2
Yeah,
plus CH3, CH2, CH.
very good. Okay, so you will break this one. This is your alpha carbon, this is your beta. Now the second one, this is your alpha, this is your beta.
CH3, C double bond O CH3
Okay.
plus
Basically, you will
CH3.
get acetone plus
Yeah.
again the acetone. Okay. CH3, CH. Yeah, this carbon pair, there will be a double bond. So what is the CH3? CO, CH3. Then CH3, CO, CH3. Right? So this is acetone. Propanone is acetone. So both are the self-condensation. Now this topic are clear?
Yes, ma'am.
Okay. Okay, so let's move to the next topic. Write down the methods of preparation of carboxylic acid. Methods of preparation of carboxylic acid. First method is from primary alcohol and aldehydes. From primary alcohols and aldehydes. Okay. Okay, so see, primary alcohol on oxidation with a strong oxidizing agent, it will give a carboxylic acid. It will give a carboxylic acid. So when primary alcohol and aldehydes, write down, give carboxylic acid on oxidation with with same number, the number of carbon should be same, right? Only you have to just oxidize the primary alcohol or aldehyde to a carboxylic acid, but the number of carbon should be same. Carbon atoms. Okay. Now, which oxidizing agent you can use? So we can use the oxidizing agent, which are strong oxidizing agent. We can use a strong oxidizing agent, just like your potassium dichromate. You can use KMnO4. You can use chromic acid. Yeah, see, there's a difference between the chromic acid, H2. Chromic acid is H2CrO4. Okay, but if you see something written as CrO3, CrO3. So this is a chromic oxide, right? Chromic CrO3. When you add the CrO3 with H2SO4, so it will become a strong oxidizing agent, which is known as Jones reagent, right? So, but if we are using the CrO3 in acetone, अगर आप इसे एसीटोन में यूज कर रहे हो या किसी भी सॉल्वेंट में यूज कर रहे हो तो इट विल बिकम इट इज जस्ट अ माइल्ड ऑक्सीडाइजिंग एजेंट. ओके नाउ आपने ये क्वेश्चन पूछा था मुझसे मुनीबा, राइट? सो लाइक इफ यू हैव टू oxidize something like primary आप aldehyde ले रहे हो, secondary ले रहे हो, so if on the arrow if it is written CrO3, okay, अगर CrO3 only लिखा हुआ है तो it means that it is a weak mild oxidizing agent. It is a mild oxidizing agent. So आप mild oxidizing agent की तरह treat करोगे इसे CrO3 को. But if with CrO3, if it is written H2SO4 along with CrO3 chromic oxide, अगर आप H2SO4 भी ले रहे हो, sulfuric acid ले रहे हो, which is a strong acid, so it will become a Jones reagent, and this is a strong oxidizing agent. Now, is it clear the difference between these two, Haniba?
Yes, ma'am.
Yeah, so when you will use the CrO3, so just treat only CrO3 लिखा है तो just treat it just like a mild oxidizing agent. So here H2 and yeah, KMnO4, okay, and you can use H2CrO4, which is a chromic acid, and CrO3. CrO3 अगर आप acidic condition में लेते हो, okay, with the H plus ion, okay, acidic condition. So it will become a strong oxidizing agent. Okay, you can take the HCl H2SO4, so it will be a strong oxidizing agent होना चाहिए इसके साथ, then it will become a strong oxidizing agent. Okay, and you should remember what is Jones reagent. So Jones reagent is CrO3 plus H2SO4. We are using these two combination, this combo is known as Jones reagent. Jones reagent. Chromic oxide plus sulfuric acid is a Jones reagent. Okay. Now, in the tolerance reagent and Fehling test. Tolerance test and Fehling test में हमने क्या देखा था? The aldehyde can be converted to a carboxylic acid, right? In a presence of a milder oxidizing agent, just like your silver ammonical nitrate, okay, and your cuprous oxide, okay, copper oxide के present में. When you add the Fehling solution A and Fehling solution B, तो आपको वहाँ पे CuO मिलता है, and it will act as an oxidizing agent, which is a mild oxidizing agent, right? So aldehyde can also aldehyde aldehydes be converted can be converted to carboxylic acid in the presence of in the presence of milder oxidizing agent such as Ag plus, okay, and Cu2 plus. Cu2 plus, okay. Ag plus के लिए आप क्या लिख सकते हो? सिल्वर अमोनिकल नाइट्रेट ले सकते हो. Okay, and for Cu2 plus, you can use your Fehling reagent, right? CuO. So aldehyde can oxidize by a milder oxidizing agent also. For example, suppose we have aldehyde, CHO group. Okay, and if you are using silver ammonical nitrate, so silver ammonical nitrate will give you Ag plus ion, right? और आप इसे किसके साथ use कर सकते हो? With a ammonia. Okay, basically silver ammonical nitrate हम use करते हैं, so that's why I've written Ag plus with NH3. So this is a milder oxidizing agent. Ag plus is a milder oxidizing agent, so it has the ability to oxidize the CHO group to a carboxylic acid. But you should be careful here. The number of carbon should be same. 1, 2, 3, 4. 4 carbon. So 4 carbon से ही आपने क्या बनाना है? Carboxylic acid. So you will write C double OH. Is it clear, Moniba?
Yes, ma'am.
Second thing, suppose if we take your cyclopentane carbaldehyde. What is this? This is a cyclopentane and this is CHO group. Okay, if we are not considering this in a parent chain, so you will use CHO के लिए हम क्या use करेंगे? Carbaldehyde. So in the carbaldehyde, if we use the Jones reagent, so what is Jones reagent? CrO3 plus your H2SO4, which is a strong oxidizing agent. So this the aldehyde can oxidized with a strong oxidizing agent तो करेगा ही, but it can also be oxidized to a carboxylic acid by a milder oxidizing agent. Milder oxidizing agent भी ये easily कर देता है aldehyde को carboxylic acid में convert. So this Jones reagent, so it will convert this CHO group to a COOH group, carboxylic acid. Similarly, third question, CHO group, if you add strong oxidizing agent KMnO4, okay, acidic condition, acidic KMnO4 आप use कर रहे हो. Okay, so here again, this will get converted into a carboxyl. The number of carbon should be same, COH group. This is clear, Muniba?
Yes, ma'am.
Okay, now let's see the second method of preparation. So we can prepare the carboxylic acid from alkyl benzene also. Alkyl benzene. Okay. So let's see alkyl benzene से how we can prepare. So when you do the vigorous oxidation of alkyl benzene, vigorous oxidation means you have to use the strong oxidizing agent, okay, in acidic or alkaline medium. Okay, you can use the chromic acid like with the acid, chromic acid CrO3 with the acid means आप Jones reagent use कर सकते हो, or you can use the alkaline KMnO4. Okay, so in a drastic condition, Okay, when you do the vigorous oxidation of alkyl benzene, so the alkyl benzene will convert it to a benzoic acid. Okay, so let's see. For example, if we take this group, this is your alkyl, this is your benzene ring, and here if I attach the alkyl, okay, alkyl group. So this is your alkyl benzene. So in alkyl benzene, if you add KMnO4, okay, which is a strong oxidizing agent, and आप इसे heat भी कर रहे हो, and if you use alkaline, basically you are using the alkaline KMnO4, means the basic condition में आप KMnO4 use कर रहे हो. So you are adding the potassium hydroxide also. You can also use the sodium hydroxide. So it will form first potassium benzoate. So when you add the alkyl benzene, mein, if you add the KMnO4 plus KOH, okay, potassium hydroxide, so alkaline KMnO4, and you are just giving the heat. Okay, so vigorous oxidation आप करा रहे हो. So this alkyl benzene will first converted into a potassium benzoate. Okay, so this alkyl group, this R group, will get oxidized. The number of carbon should be same, right? So this will get oxidized to COO minus and K plus. So it will form a salt here. Okay, what is this? This is your potassium benzoate. Potassium benzoate बना लेते हैं. After that, when you give, okay, when you provide the acidic condition, okay, जब आप H plus ion देते हो, okay, when you give the H plus ion or dilute H2SO4 or dilute acid provide करते हो, so it will give you H plus ion, and it will replace this HK plus, okay, K plus with a H. Okay, जो ये K plus निकल जाएगा and hydrogen will get attached over here. So it will form a benzoic acid. It will form a benzoic acid. So by this method, you can also prepare a carboxylic acid. Okay, aromatic carboxylic acid here. Is this clear, Aniba? This method?
Yes, ma'am.
Okay. So basically, we have to do the vigorous oxidation of alkyl benzene. For example, if you take the toluene, suppose we just take the toluene. So how you can convert the toluene to a benzoic acid? So first, you will treat this toluene with MnO4. Okay, basically, आप alkaline के MnO4 लोगे and heat provide करोगे. So it will get converted, this H3 hydrogen will get replaced by COO minus and K plus. It will form potassium benzoate. If you are using sodium hydroxide over here, so it will form sodium benzoate. Okay, just यहाँ पे आप क्या attach करोगे? Na plus, COO minus Na plus. Now, when you give the further H plus ion, so it will get converted to a benzoic acid, C double OH over here. Next example, suppose if I give you this one, 1, 2, 3, 1, 2, 3. Okay, the alkyl group here is propyl, 1, 2, 3 carbon, propyl group. Okay, the same. Okay, I've written KMnO4, alkaline KMnO4 plus heat. So what will be the product? Okay, just quickly write it down, method of preparation, and after that, just do this question.
Benzene with CH2, CH2, COO, okay.
Yes,
And then
the
we're going to
final
give H
product.
plus.
Yes. So at the last carbon, you will attach the COOH group. The number of carbon should be same. At the last carbon, you will attach the COH group. Okay, quickly note down all the examples.
Done, ma'am.
Okay. Okay, so see here. So in each and every group, you will get the C. Here, the mechanism will be different because you know very well benzylic carbon is this benzylic CH2. This group is more reactive, right? So it is more reactive. So you will form basically this bond will cleave. Okay, this bond will cleave over here. So here there are two. The mixture of two compounds will be formed basically, and your primary compound will be a benzoic acid. क्या होगा यहाँ पे this is something different. Okay, so this is your if CH3 group is attached. Okay, one carbon is there, then it is very simple. You will form the benzoic acid, only benzoic acid. But if there is more than one carbon chain, okay, if it is ethyl group, if it is propyl group and any group, so you have to cleave this bond because मैंने आपको पढ़ाया था in the haloalkane chapter. This benzylic carbon, see this benzene ring, and here is a carbon group. So this benzylic carbon is more reactive. Okay, because it is more reactive, so you will form this bond will cleave over here. यहाँ से ये bond break होगा and it will form, see the benzoic acid plus this two ring, this 1,2 carbon, it will again oxidize to CH3, C double OH. This will be formed in this case. Is this clear, Muniba? This one?
Yes, ma'am.
So here you will get two products. Okay, but the major product is always the benzoic acid. Okay, if in your exam they ask you to write on the major product, so you will write benzoic acid. Okay, next one, third method of preparation is from nitrile, from nitriles and amides. And amides. Nitrile is CN. Okay, cyanide or nitrile, you can say both are same. So from nitrile and amides, how you can prepare the carboxylic acid? So suppose we just take the R carbon triple bond nitrogen. Okay, this is your nitrile. Okay, and nitrile may when you add the water H2O in nitrile, when you add water, so what happens? What you're supposed to do? Two hydrogen and one oxygen is there, right? Two hydrogen and one oxygen is there. So you have to break this two bond. Okay, just break this carbon and nitrogen double bond. Two double bonds आपने break करना है and just attach two hydrogen to this nitrogen and one oxygen to this carbon. Okay, by a double bond. One oxygen आपने क्या करना है? Double bond से attach करना है. Right. So this will form R CO CO NH2. And what is this? This is your amide. Okay. So in the nitrile, when you add water, so this cyanide or nitrile will get converted to amide. Okay. This is amide. ये किस में convert हो गया? Amide में RCO NH2. This is your amide. Now further, when you do the acidic एसिडिक कंडीशन में आप हाइड्रेशन करा रहे हो. ओके, इफ एसिडिक कंडीशन में आप हाइड्रेशन करा रहे हो, सो इट मींस आप वाटर भी प्रोवाइड कर रहे हो और एसिड भी दे रहे हो. मींस आप डाइल्यूट एसिड प्रोवाइड कर रहे हो. यू आर जस्ट प्रोवाइडिंग द डाइल्यूट acid. Okay, so that is acidic hydration in the presence of acid, right? Acid hydration, so it will give you a H plus and OH minus and okay, and आप heating भी दे रहे हो, heating conditions में हो रही है. So what happens over here when the amide, okay, when the amide undergo acidic hydration, what you are supposed to do? This NH2 is there, right? So here HOH. This is HOH, right? So you have to break this bond. आपको ये bond just a second, not this bond, this OH bond. H H O H. So you have to OH. You are supposed to give it to this carbon and just this bond. Okay, ये bond break होगा. NH3 will be formed. NH2 will get combined to one hydrogen, right? NH2 will get combined to one hydrogen. So basically आप ऐसे समझ सकते हो just a second. So basically, you are doing the acidic hydration. So you will get a H plus and OH minus, right? So H plus will get attached to the nitrogen and OH minus will get attached to this carbon. So it will form RCOOH, carboxylic acid, plus your ammonia, okay, plus your NH3. So that is the mechanism for the method of preparation of carboxylic acid from nitrile and amide. So if there is a nitrile group, so first we have to convert that nitrile group to a amide by providing the water. When you add water to it, so it will convert to a amide. And after you get the amide, just do the acidic hydration, right? OH will get attached to the carbon and the hydrogen will get attached to the nitrogen, and this bond will break and you will get carboxylic acid plus ammonia. Clear, Muniba, this concept?
Yes, ma'am.
Okay. Okay, so write down some homework. This is a CN group. Okay, you have to follow the same mechanism. First step may just do the hydration. This is a nitrile. So this nitrile will convert it into a amide in the first step when you are just providing the water. But in the second step, when you do the acidic hydration, H plus ion there, acidic hydration in the heating condition. So what will be the product? Second question is aromatic system लेती हूँ मैं and just attach the cyanide group. The condition is same. First step, hydration. Second step, acidic hydration. Third question, this one, CO and H2 group. Okay, these three questions. Okay, just follow the proper mechanism and write down the product.
For the last one,
Yes,
what do we do?
for the last one,
Yeah.
it's it's NH2, it's amide, right? Directly I have given the amide. This is the step, amide, right? But here the
Okay.
condition, right on the condition, you have to do the acidic hydration only, right? This is amide. You can see this is so amide. When you do the acidic hydration, what will be the product? This is very simple. Just attach the H plus to this NH, okay, nitrogen and OH to this carbon and just break this bond. Okay, you will get your benzoic acid, okay, benzene with COOH, and you will get ammonia.
Done, ma'am.
Okay, then Muniba, I stop this class here. I will share the notes after this class. I think you have your notes,
Mm.
right? Okay.
Yes, I
Okay,
do.
so please, yeah, please revise the notes, and if there's any doubt, you can ask in the next class.
All right, now. Thank you so
Okay, bye
much.
bye.
Yeah. So, good evening, guys.
Good
Sorry, I
evening.
got
Good
a
evening,
bit
ma'am.
late. Okay, let's start. Just give me a second. I'll join from the tab and then we'll start. Today, we have to start the naming of the functional group, right?
Yes, ma'am.
Okay. उससे पहले वाला is clear, Mohammed?
Yes, ma'am. It's just naming basically.